Welcome back. This is Mr. Hassan's Maths channel. I'm now answering question number 16 from the October-November 2021 International IGCSE paper from Cambridge, CIE. This is a 0580. This is paper 2, variant 1. Okay, now this question here is about sequences. And part A, it's a type of sequence here which when you look at it straight away, it looks, obviously it's not an arithmetic sequence, because for arithmetic sequence you have to add the same number to get to the next term. We can see that it's increasing by a great amount each time. All right, so one of the first things we should try to deal with when we're dealing with sequences is see how to get from one term to the next. So what we can do is we can take the terms and subtract them and see what happens. So 15 minus 8, of course, that's 7. Okay, so to get from 8 to 15 you have to add 7. And then to get from 15 to 34, well, 34 minus 15, that gives you 19. And then from 71 to 34, that gives you 37. And then from 132 to 71, that gives you 61. So of course it's not an arithmetic sequence. If it's an arithmetic sequence, you get the same number each time. Okay, it's not a linear sequence, so we can't. It's not like something times n. All right. So now the next thing we're going to look for is to see if it's quadratic. We'll do that by looking at the second row of differences. So we'll take these differences here and subtract them as well. So I'll do 19 minus 7. Okay, that gives me 12. Then you have 37 minus 19. Well, that gives me 18. And we have 61 minus 37. And that doesn't give me a constant, but it gives me something which I can see that the next row of differences. So I know it's not a quadratic sequence, right? So, but the next row, we can see 12 to 18, that's plus 6. 18 to 24 plus 6. So it looks like it's got something to do with the third row of differences. And that means it's related to n cubed. All right. Now, with cubic sequences, if the number comes up as 6 like it does now, we know that it's got something to do with n cubed. So what I'm going to do is I'm just going to write n equals 1, 2, 3, 4, 5. We have 5 terms. I'm going to write n cubed. Now n cubed, 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, and 5 cubed is 125. Then I'm going to write down what our sequence is. Our sequence is 8, 15, 34, 71, and 132. And I'm going to compare them. I'm going to say, how do I get from our sequence to that number? Well, we have to add 7. 8 to 15, again, I have to add 7. 27 to 34, again, I have to add 7. 64 to 71, I have to add 7. 125 to 132, I have to add 7. So we can see our sequence is n cubed plus 7. This is the plus 7 part. So our sequence is n cubed plus 7. So we can work out our sequence using that. Now, this is not a normal type of sequence that you don't normally get these cubic ones. All right, but that's how you would go about working out something like this. Okay, you'll find that the third row gives you a constant. Now, if it gives you a constant of a plus 6, that means it's going to be 1n cubed. That's what you have to remember. You don't have to really remember that. I don't think they'll give you anything more complicated than that. That's fine. If it came out as a constant on the second row, then it'll be something to do with something times n squared. Okay, so this is an example of a cubic sequence. It doesn't come up that often, but as we can see here, it can come up. So it's something that you should be wary of. All right, so that's what we can see here for this cubic sequence. Now, for the part B, we have these fractions. And when you're dealing with fractions, what you normally should realize is, in most cases, the numerator and the denominator will have two completely separate patterns. And we can see that that's the case here. The numerator we can see is 2, 3, 4, 5, 6. The numbers are increasing by 1 each time. Okay, so if they're increasing by 1 each time, that means there's a common difference of 1. The first row of difference will be a constant of 1. That means it's got something to do with the 1 times table, because numbers that increase by 1 each time are related to the 1 times table, because the 1 times table increases by 1 each time. Okay, so it's got something to do with 1 times n. So the numerator is going to have something to do with 1 times n. And we have to think about it. If the first term is 2, okay, This will give us 1. We have to make the first term 2, so we've got to add 1 to it. All right, so you end up with n plus 1. And we can see if it works when the first term is going to be 2, the second term is going to be 3, the third term is going to be 3 plus 1, 4, and so on. We can see it helps us to give the right number for the numerator. So that's definitely, for the numerator, the correct nth term. Now we've got to think about the denominator. Now the denominator, we can see here that the numbers are changing in a way that it's becoming bigger, almost like this one. However, we should be able to spot something that if we multiply each term by 4, we get to the next term. So we could test that out if you want to. Say 256 divided by 64, that gives us 4. And 64 divided by 16 gives us 4. And 16 divided by 4 gives us 4. And 4 divided by 1 gives us 4. So here we have a common ratio. We have the same number we've got to multiply each time. So this is going to be an exponential sequence. So it's going to have something to do with 4 to the power of n. Okay, so whatever number you have to multiply by to get to the next term, you multiply by 4, multiply by 4, multiply by 4. In this case, you had to add 1, add 1, add 1, add 1. If you have to multiply by 4, it's got something to do with that number you're multiplying by to the power of n. Okay, but we got to adjust it. We want the first term to be 1 in the denominator. Okay, that will leave the first term as 4. Okay, so our first term, we want it to be 1, but our first term is actually 4. The second term, we want it to be 4, but we want it to be 4, but if we leave it like this, the second term is going to be 16. And the third term, we want it to be 16, but if we leave it like this, it's going to be 4 to the power of 3, which is 64. So we can notice that the first term in our sequence here, 1, 4, 16, that's actually, in terms of 4 to the power of something, that's 4 to the power of 0. And this is 4 to the power of 1. And this is 4 to the power of 2. Okay, so the number here, 1, okay, is 4 to the power of 0. The number here, 4, is 4 to the power of 1. The number here, 16, 4 to the power of 2. So the first term is 4 to the power of 0. The second term is 4 to the power of 1. The third term is 4 to the power of 2. So it's like 4 to the power of n minus 1. So you have n plus 1 over 4 to the power of n minus 1, where the minus 1 is in the power. Okay, so that's how we can work out the nth term of this sequence. So n plus 1 over 4 times 4 to the power of n minus 1. Okay, that will give us this sequence here. When n is equal to 1, you're going to get 4 to the power of 0, which is 1, which is what we want. When n is equal to 2, you're going to have 4 to the power of 1, which is 4. When n equals 3, you have 4 squared, which is 16, and so on and so forth. So there is the nth term of this sequence. Now, this sequence question is a bit more difficult than the ones that you would normally find. Okay, especially the you got a cubic sequence, which is not that normal, and you got this exponential sequence. So you have to be aware of these type of sequences. All right. So how do we find out that this, like for example, this 1, 4, 16, 64, 2, 5, 6. If we follow the same approach here, we wouldn't have got a constant. All right. You would have got, you wouldn't have a constant in any of those three lines. Right. So that wouldn't work. So you think, okay, let's think of another relationship. And the only other relationship that we're dealing with here is when you multiply by the same number each time to get to the next number. And we can see that's exactly what we must do. Multiplying by 4, then by 4 again, then by 4 again. So it's got something to do with the number you're multiplying to the power of n. Okay, so that completes this question number 16 from this paper. I hope that was clear. Thank you for watching. Other questions from this particular paper can be found in the playlist that will appear up here. Other questions from the topic of sequences and series and number patterns can be found in the playlist that will appear over there. You can subscribe to my channel by clicking on this link. Thank you for watching and see you soon.